Hello everyone, in this video we'll calculate the entropy for an ideal gas. So let's get started. First of all, we need to suppose that the entropy is a function as T and P. So then we're able to compute what is the differential of the entropy. That's this expression over here. The differential of the entropy will be equal to the derivative of s with respect to t dt plus the derivative of s with respect to p dp. In previous video, we've demonstrated that Cp is equal to this expression. Cp is equal to T times the derivative of S with respect to T at constant pressure. If you would like to know how to calculate this expression, I'll give you the link for the video if you want to know how to calculate this expression. So now we need an expression for this term. We need to solve that expression from here. We'll get that the partial derivative of the entropy with the pressure is equal to Cp over T. Furthermore, we need an expression for this part. So we need to use the differential of the free Gibbs energy. And that's this expression over here. So, before to continue this demonstration, we need to remember some mathematics. Questions. For example, if we have a differential equation like that, where m times dx plus n times dy equal to 0, this differential equation is an exact differential equation provided that this is true. The partial derivative of m with respect to y is equal to the partial derivative of n with respect to x. If that is true, we must apply this theorem for this differential equation. So that means that the partial derivative of the volume with respect t must be equal to minus the partial derivative of s with respect p. That is the expression that I have in here. Or we can change this negative sign to the other side, multiplying both sides by -1. We'll get this other expression. Now we have an expression to replace this term and this term. So now we know that the partial derivative of s with respect to t is equal to Cp over t, and that this term is this expression over here. The derivative of s with respect to pressure is equal to minus the derivative of the volume with respect to temperature. And we replace in our original equation for the differential of the entropy. Now we need an expression for dV and dt. For that expression, we must remember that Betta, that is the expansion coefficient, isothermal expansion coefficient, is equal to 1 over V times the partial derivative of V with respect to t. From this expression, we're able to solve for this partial derivative, like that. So only this term that is dividing pass to the other side multiplying. Now, if we replace that expression in our equation, we'll get this other equation. In previous video, also you can watch the link in the description. We know that beta is equal to 1 over T for ideal gas. So we can replace this value in here. We have it in here. Simplifying a little bit more. And so now, in order to integrate this differential equation, we need to write all these terms just in terms in temperature, exactly like this term. And in this term also we need a term only with pressure. In order to do that, we need to use the ideal gas equation. Let's go to obtain V over T from this equation. For example, T that is multiplying pass to the other side divided, and this expression that is P that is multiplying in this side pass dividing to the other side. And we have this other expression. So we can replace this expression over here. Let's do that. So we have that ds is equal to Cp dt over T minus nR over P times dP. We can write this last equation like this, and in this point we can integrate both sides of the differential equation. In this side, let's go integrate from the entropy 1 until entropy 2, from the temperature 1 to temperature 2, and pressure 1 to pressure 2. Solving those integrals, we'll get that S2 minus S1 is equal to Cp, a natural logarithm of T2 over T1 minus nR times the natural logarithm of P2 over P1. Or we can rewrite this expression as delta S. Besides, this result that we get in here, if we return to the first equation, this first equation for ds, if we multiply both sides by t, we'll get that t ds is equal to Cp dt minus V beta T times dP. Or we can rewrite this expression like delta Q. Remember that this expression is the same that write delta Q. And this is the other expression that we were looking for. So now that's it for today's video. Thank you very much for watching and see you next time. Take care.